Good morning. Hi, this is Mr. Gannon again. We're going to kind of explore a little bit more about energy and springs. So we all go take a ride here in the morning in a car, probably, or on a bus. The bus has some pretty heavy-duty springs for the suspension. So the bus sits on the springs compress, and when it goes over bumps, the springs are able to kind of react to that. Springs are in our lives pretty much everywhere. Okay, our tendons act as springs. There are tiny little springs in the watches that you wear, your computer, even even your cell phones have tiny little springs and mechanisms in there to help keep the item running properly. So if I drew a picture of a spring, okay, I would draw something like this. Okay, there is, I hope you can see that. There's a spring. Okay, a spring's strength is recorded as something called a spring constant. Now, if you could probably guess, the higher the spring constant, the stronger the spring is. Okay, the more it takes to stretch it or compress it. So this is a measure of spring strength. Okay, it's a measure of the spring strength. Okay, now we call it K. Okay, it's a spring constant, and we do have a formula for that. Okay, I'm going to give you that right now. Okay, here it is. Force equals negative kx. Okay, this is the force applied to the spring. This is the spring constant. And this is the distance that the spring stretches. Okay, so the question might be, I'll write this down actually. This is the force. This is the constant. And this is the stretch. Okay. Force, constant, and stretch. So, if I wanted to find out how much force, here's our little spring of science here, okay, how much force it would take to stretch a spring with a certain constant, a certain distance. So let's just figure it out here. Okay, we're looking for force. Let's say I have a spring with a K value of, let's see, 2 newtons per meter. Okay, we'll get into the units later on in class. And then let's say I have a stretch distance of 1.5 meters. Okay. Here's the spring. The springs have a constant. The way they're built in the factory, they all have a constant, unless you pull them too much. They stretch out. We stretch it 1.5 meters. What force will it take to stretch that spring, our spring up here, 1.5 meters? Force equals negative K. There's our 2 times X, 1.5, and we're going to figure out how many newtons it takes to stretch that spring a certain distance. So I'll get my calculator out very simply. I really probably don't need one, but we'll do it. 2 times 1.5, okay, is the force needed is 3 newtons of force needed to do that. Stretch that spring out 1.5 meters. Okay, that's a quick video on spring constant. Let's stop here, and I will we'll do a couple more examples, and we'll also give you the energy of a spring as well. But that's the basics okay, for spring constant. Let's just go back over that quickly. This is the force required to stretch a spring or compress it. Compress means to like push it together. Stretch is to pull it apart. K is the K value of the spring. That's like how strong the spring is, how heavy it is, how much it can actually hold back against. And X is how far you can stretch it or compress it. Okay, so we're talking about compression and stretching. And when we look at it, it's actually a pretty simple formula. To get the force is pretty simple. We are going to have to take and solve for X and solve for K in a lab that we're going to do later. All right, thank you so much, and have a wonderful day.